understood as a way of communication as well. So similarly in Pega, correspondence is the rule that is going to help you integrate, or not even integrate, like communicate with the external system. So it's not exactly integration, but you can just communicate with the external system. So if you see here, go to the records, and under process you will find this thing that we're talking about called as correspondence. So what this, if you open any of this correspondence, primarily I think in your CSA you must have learned that there are 4 types of correspondence that Pega supports. So if you see here, those are email, fax, mail, and I think page are also one of them. So generally 4 types of correspondence. It's not important for us now. For now, what's important is to understand how you have the different correspondence rules here. Okay, so if you see here, you have an option. If you open this, and here, let's open one of the correspondence rules. You can see here correspondence details of the work item. Okay, so it says entered by, then the item description and work summary, and this is the item type. So what's really important for you to understand is that this correspondence is going to help us in the flow. Say for example, when you're going to send an email, you need this particular correspondence. Okay, so if, say for example, in this scenario, say so you can have something like either notify, or you can just say that you open this process. Okay, let's change this to like update claimant. Let's say update all parties. Right. So what I'm expecting here is it would send out an email to all the parties with whatever changes that you have done. So if you see here, it says it opens the same ID as notify, just that the flow label is alone changed. So what we can do is we can change that. We can just edit this flow here. We can put a smart shape for, say for example, something like a send email. So what that would do is you would see that there is an option to send to an email address or send to a work party. But what's important for us to know here is the sub correspondence and the message. So you have a rich text editor where you can type in all the things you want, or you could, if the thing with rich text editor is like it has to be a static information. Okay, like you cannot enter your own information, whereas dynamic information, say for example the case ID and things like that, whereas in a correspondence rule you can enter all those things. So if you see here, we have the one called the details, or say for example, let's select the one resolution because you want to send resolution mail. So if you open this correspondence here, so it says, you see here, this is, it says we are glad to inform you that we have resolved the following, and then you have a when condition check. Based on that, some check is going to be done. Then requests, else, then we say we give a request condition, and then we say contact reference, and then we give the PY ID, which is the work object ID, and then we say received on, and then again we give .px3 data. So what has actually happened here is we have ensured that all the values that we have here for this particular case are, if you see here, let's see what are the dynamic values here. Okay, so this include is dynamic. Then it says with embedded page, PA work party of customer, include stream header, and this is also dynamic. And then if you see here, there is a when condition, when that's dynamic, else when that's also dynamic, PYID again, that's the value is dynamic. So if you see here, in effect, the correspondence rule is a good good rule to have that has both static and dynamic information with all the available formatting too. So here this is a rich text editor. You have all the colors, fonts, all of that what you want, all that is possible here. Now if you go to the source of here, if you just click on source, this actually gives you the exact the HTML view of it. Okay, so this is also pretty important for you to understand that this HTML option here is just going to as you can actually write the proper HTML code here and then do that, or you could just use the normal tab viewer like this one here and then set the value as well. Okay, so yeah, so after some time we will create our own correspondence rule, and in that we will enter our details and we will make sure that we can include dynamic property values. Okay, so yeah, so again to repeat myself, so if you see here this particular image is, well, you have the option to either send a correspondence or a static rich text here. Okay, so this is what happens in some of the systems, but mostly you need the dynamic value. So say for example the same case ID, it's on the same case ID, you might tell customer that these information is changed or things like that. Okay, alright, so that was it about the resolution template. Now now what you need to understand is, say for example, now that we are going to send the email, it has like basically 4 steps that you have to be aware of. Okay, so first is the configure recipients. So make sure that if you're sending it to a work party like this one, that it has a proper valid email address. Okay, then you have to have the sender information, who's like from Pega. We're going to send it from Pega application, but you need to know beforehand who, like what is the email ID that you have to use. Say for example, the email ID could be like it could generally you would say no-reply something, right? That's how you get automated emails from customer systems. Or you can say admin something. So you can use any sender information, but you can say who is the person who's sending it. Like you can select by yourself, like as I was saying, no-reply or something like that. But the other information like the email account, so that is held in a rule called as an email account rule. What this would have is the SMTP server, which is the secure message transfer protocol server. So what the server will do is, it is the server which is used to send out the email. Okay, so the SMTP server here will need to be even thought through, like that it should have the IP, okay, and it should have the port number. Then it should have whether it is SSL or not. So all the information regarding the server. So even the server username, password, that is the other thing that you have to be aware of. Then obviously I was talking to you about the correspondence rule, and that needs to be there. And one interesting thing about correspondence rule is that you can have the correspondence rule itself can be made up of some other rules. Like it can be made up of fragments, can be made of some other rules, made of other paragraphs. So if you see here, there are some more other things like this correspondence fragment. Then there is something called as a paragraph. I don't know if it's in here. So what these are is they are again small reusable entities that you can embed inside the correspondence rule. Okay, so yeah, so that is about the correspondence fragments and things like that we have. So you have correspondence fragments. So again, those are like small reusable entities that you can embed in a correspondence rule. So say for example, you see here it has the UI is not as smart as the other one, but if you see the references, right. I'm just seeing the references, give me a second. Correct. So think the flash install, but yeah, but know that correspondence fragments are again the literal meaning smaller fragments of the correspondence that can be reused. Okay, and you can have another type of rule called as paragraph. So I think that you should find out versus segment if I'm right. No, I think that's under. Yeah, to the user interface. So if you open this rule here, again, this is also so I think this also has a rich text editor, which yeah, you see this is a rich text editor, and it's much like the correspondence rule. It has slightly lesser features, but it has almost all the things that we are primarily looking for. In terms of you can even embed images, you can have your own style formatted, but again these are also reusable entities, whereas correspondence fragment was just directly the HTML code itself, and whereas this is the other one that we have, it's like the paragraph. So you can you can reference some paragraph rule and all that here. Okay, right, now moving forward, now let's see how we're going to use the email here. So generally, again, because we are talking with an external, communicating with an external system, Pega has a wizard that does that for us. So all that you need to click on Designer Studio, and then you say integration, and then you have email, and then you have the email wizard. So what this will do is this will generate all the rules that can be used to send and receive emails. Okay, now if you see, take a look at here, but here primarily it will create all these rules on the back end, the email account rule, and yeah, things like that. So now, yeah, I think one more thing here that you have to notice is we have the delivery option. So the question is how you're going to deliver the email. You can use a send email smart shape. You can have a notify option and assignment. Then even in SLAs, you have the option to send email when the SLA is reached, when the goal or deadline is reached. You can automatically make the system send an email. or you can have some ad hoc tasks or things like that. So that is the other option that we have. Now in the correspondence rule, you have the option to include these things. So what this does is you can open a correspondence rule, for example like this. Let's give you a good example of good definition of a correspondence rules. This is the definition. I will just put it up here on the notes. So this is right. So this is the correspondence rule definition that we have. Just take a look at it when you're free. But I think I should have a wrap. Right. Now this correspondence rule has the ability to embed other rules inside that. So as I was showing you, we saw paragraph, we saw fragment, probably another correspondence rule, and even a section. So let's see where we do that. So if you open this as a correspondence rule, you have an option called here as insert rule. Okay. And you have an option called as insert property. So if I say insert property, it will show me when you can give the property name, and you can decide when to insert the property or when the property is to be shown. The other option is the other types of rules that we can include. As you can see here, we can include a paragraph, section, another correspondence, and a correspondence fragment. Okay. So primarily all these boils down to the fact that you can give good options, good other rules that can be integrated into this particular correspondence rule. That's going to help us in the long run. Okay, so they are reusable entities that we can put into the system. Alright, so again here you have the when condition. Then you have the naming convention, the using page option, all this. Okay. Alright, so that is some of the other options that are there. Now, moving forward, just telling you have the option. So, yeah. So one important thing to know here is once a correspondence is sent, it is attached to the work item, and it's a permanent record that ideally cannot be deleted. Right? This is how the wizard the email account rule looks like. So you have to select say from, and then you have to select the user ID, password. Fine. If you're using the Gmail as a email service provider, the SMTP service provider, and that is done using that. For that, you will have to enter smtp.gmail.com. Right. So this is. Yeah, so that's a theory about correspondence rules. Next, we will learn a bit about tickets. After that, a bit about declarative rules, like what is forward chaining and backward chaining. So yeah, so now let's look at the tickets concept. So know that tickets are a feature in Pega that support flow execution, but which is completely out of the normal processing. Say, what I mean by that is, if you have a flow like this, say for example, if I open a flow, we just close all these. We can configure this later. Say for example, I have a flow like this. So this all happens in real world, where you have like multiple assignments. Then you may have a decision shape, okay, and then you may have a shape here, assignment. So the assignment here. So let's say that this is enough complicated, a small complicated flow, but in real time you might have like maybe 10 or 15 assignments, and you can have the decision shape, you can have the end shape, and all these things here. Now, what's important to know here is all these options that we have, they're going to help us in the sequence in which the flow would go. Is you have the start shape goes here, then you can have a flow action that takes it here, then you can have a decision shape which goes here and then goes, or you can use the other path. Now what's important to understand here is that these smart shapes and all these things, these flow processing that we have, at times we might want the sequence to be broken. So what I mean by sequence to be broken is, say, let's make it a little more neat. So, okay, take my cue here that you should do it only in very rare scenarios. Okay, this is ticketing is to be used only in very rare scenarios, which would be characterized as out of sequence execution, flow execution. Okay, so if this is the sequence that we have, like say for example, if this is the sequence that we have, okay, or comes here and then goes here, or comes here and go. So all these paths that is already there in the system, that in the same for example in this image, these are all the normal flow processing paths. Okay, these are not out of event or a business exception that we can have. But what if there was a scenario wherein it said that you want to jump to, you are, say for example, you're in this particular assignment, and on click of a button you want to jump to this assignment, right? So now that you can achieve using you can just create a connector here and then just connect back to this one like this. Okay, which is fairly possible to do. It shouldn't be complicated at all to do it. But do does this normally happen? The answer should be no if you're going to use a ticket to solve this problem. This is a business exception. That is a rare chance that you can get this scenario. So then what you need to do is you have to create a ticket on this particular assignment. It's normally tickets are represented like this shape, and from this particular assignment we will have a button or something that would set the ticket from this particular assignment, and it would easily help you jump to this assignment. The same as the connector shape that I put it, just that here we can easily jump from one assignment to another assignment within a flow without any difficulties. Okay. Yeah, so you can have out of sequence events. It need not be even going backward. If you are, say for example, you are in this particular assignment and you want to jump directly to the end shape, even that's also possible. You want to jump directly to this assignment, even that's also possible. So yeah, so to the question, can the jump or the flow both backward and the forward if we use ticket? Yes, we can jump forward and backward or anywhere in the flow, provided that particular ticket is invoked. Okay. Now that is thing that you have to learn about ticket, that you have to know about tickets. Now if you see here further, yeah, so now if you see here we have where all we can refer tickets. So these are all the shapes, most of the smart shapes and all these options where you can refer tickets. So let's see how we can do that. So remember, we want to jump to this one, we want to jump backward now. So what we can do is we can just open the target assignment, expand the ticket here, and then I can just set the ticket name. Okay, so I can give like something like okay, I'll give a name like review again or something, or I say reject. Okay, I say defer. So what you can create your own ticket rules for that matter. So it says this is how a ticket rule would look like. It just has only the history. So it's considered more like a flag. Okay, so if you just submit this one here, so yeah, you can see that the particular it shows like this now, the defer. Right. Now all that you need to do here is you just need to jump whenever you come here or you're in this particular assignment. You just need to jump from here to here. Okay, so we know that this is a flag and we have to auto tell the system that hey, you want to move from this assignment to this one. Right. Now if you go to here, you have some standard tickets which are already available which are already given by Pega. So they have some use cases. You can just go through them after this. And yeah, tickets. Yeah. So again, I want to re-emphasize this fact. It's only to be used for business exception events, but you can again go for alternate stage, which is also as a business exception, or a weight shape, or using a decision shape. So once you're sure that none of those features work, only then you should go for a ticket. Okay, so once you do the exercise, I think this should be a bit more clear. But this is how, if you see here this exercise, say for example, I'm going to sum up that. Right. So here currently I'm in a flow. Here it says investigate the claim, and this is my target that I want to jump to. Instead of say for example, I don't want to send it for review, I want to directly come here. So that is possible. This is if you use ticket. See here, it has directly come to this point, this one here. But if you have not used ticket, normally after this one, it comes to this point. Okay. So just know that ticket is like a magic trick that we have in our box that you should use only if there is and only in rare scenarios you should use it. Okay, and now you can wonder whether this ticket works outside of a flow. Yes, very much. So if you're between two flows, then now the only condition there is that flow has to be active already. So you have, say, for example, you have flow 1 and flow 2. Then you want to move from flow 1 to flow 2 using ticket. You can do that, but provided both the flows are active, that you should have an assignment on both the flows. Then it's alright to jump. Alright, now the other thing that we're going to learn about is called as declaratives. So yeah, I think we'll just quickly go over this theory, and after that we can get started with the exercises. Now, generally, you have to understand the declarative rules that are available in the system. So you have a lot of declarative rules which start with declare name as a prefix, like declare expression, declare constraints, declare trigger, things like that. So let's see here. So we have now with declarative rules, the key concept that you have to understand is that it will work without you having to procedurally call it. That is a key concept here. That in a traditional programming language, you will have to enter the sequence of steps to do something, but using a declarative rule, if you have set some particular task to be done, it would get executed without you having to explicitly call it. That is the important, that's a key power, I would say, of a declarative rule. So you just write it, and it will, you create the rule, and it will automatically work without you having to create things manually or things like that. So the options that we have is, say, for example, like, yeah, this one here. The declarative, say, the use case here is, yeah. So we have the cost, we have the disease repeat grid. Now the important thing here is, if I say, for example, the estimated cost of treatment, okay, for each of those, I can write a declare expression rule, okay, which will take all the sums. So say, for example, I enter like 5 diseases, and I enter some amount for each of these diseases. And so what happens is, using the normal processing that is available on a decision declarative rule, it will sum up all the values and it will show it to me. So it does the calculation of the sum for all the values. Right? So that is one of the practical use cases of a declarative expression, a declare rule. So you have written that logic once, and that would ensure that it works almost all this time without you having to explicitly go ahead and find those particular rules. Okay, so you don't need to explicitly, but this is particularly useful for developers and helps reduce the bugs as well. So since you've written it, it works in almost all the places indefinitely, and you don't have to worry about creating it all over again and things like that. Right. So now with declarative rules, there are 2 key concepts that you have to understand on how it's executed. First one is called as a forward chaining, and the other is called as a backward chaining. Okay, so let me explain to you how this works. So to execute the declarative rule, we have 2 approaches. Basically, the approaches are based on the fact when you want the declare rule to be invoked. Okay, so based on this, we have two approaches. One is called as forward chaining, which essentially means that when input changes, okay, invoke the rule. Or the other one is backward chaining. So what this does is when so obviously the opposite of this one. Forward is whenever input changes. Backward chaining is when property value doesn't exist, etc. Right? So you have a couple of other options also for backward chaining. Now with forward chaining, what you have to understand is you have these good options are available. Say for example you have you're going to do a sum of two properties. Okay, that is a plus b equal to c. Now what's key for you to understand is whenever either a or b changes, so if a or b changes, then you want the system to automatically recalculate the sum, that is c. So using this approach is called as a forward chaining. So the system will always have a monitor on a, property a and property b. So it will keep checking where are these properties, and as and when these property values get modified, it sums up it as the value here like c. Right, so that is an option that we have. Now the other option that is available is called as backward chaining. So what that would do is, say in the same scenario that is a plus b is equal to c, it will always check, say for example you are going to ask for the value, the result value c from your section or something. Say for example you're going to embed the property, use the property c, then system tries to go and find a and b. Right? So that is important for you to understand. So with forward chaining, it says whenever input changes, invoke the rule, and with backward chaining, it says that whenever you're going to use the property c, the system automatically tries to go and find the property values a and b. Okay, so if you just follow my cursor here, forward means you go ahead and you essentially go and look at the inputs and then you calculate c. But with backward, you actually come from this side, you try to systems try to find the value of c. Because of that, it's going to go and check what about a and b, and then it's going to calculate it. Right. So yeah, it's this concept is as simple as this, but you have to understand when to use these. Okay, so again, this is a very commonly asked interview question, which is a better option here. So we will see it's not, there's no hard and fast rule that forward chaining is better than backward chaining and all that, but generally forward chaining is only better than backward chaining because sometimes or most of the times whenever it's not the logic is not going to be as simple as like a plus b equal to c. It could be a really complicated logic involving multiple variables. So what happens is when it tries to recompute all the initial ones, then it goes on a very long list of properties that it has to seek and find, and that takes time. Okay, so backward chaining is generally more resource intensive than forward chaining, but yeah, so but again there are scenarios where you should use one over the other. let's see where we're going to use it. So let's look at the theory a bit more. And if you see here, forward chaining provides automatic propagation of changes in one property value to cause recomputation of another property value. Okay, so whereas whenever input changes, it goes and recomputes it. Okay, so again, there are some other options that are available in terms of the theory. Just take a look at it. Again, they say if the area of the property depends on length and width, and the volume depends on area and depth, forward chaining causes the volume property to be recomputed each time length or width or depth changes. Okay, right. So the other option that is available is called as backward chaining, which is the propagation. So these are like basically the decision is when you want to when you want the rule to be invoked. That's when you can choose the chaining mechanism. Okay, so it says executes declare expression when the value is needed for the property, and these are the options. So it says when used if no value is present, if property is missing, or if you say whenever used, which means that always it is going to have to recompute the options there. So even you get a guardrail warning whenever you use the backward chaining with this option called as whenever used. So let's see where these are, like, just to make a little bit more sense. Say for example, you can actually configure what type of propagation you want only in this type of declare rule, not in any other type of declare rule, that is the declare expression rule. Say for example here, so if you go to this change tracking option here, you will have this option called as all these options here. So it says whenever inputs change, this is forward chaining, but all these other options, when used if no value present, when used if property is missing, and whenever used, these three are for backward chain. Suppose I select this one, so I think I get yeah, it says avoid the whenever used option for change tracking. But because of this reason, you can claim that no. I think the question that's being asked here is it doesn't say if you use whenever used, which is the scenario for backward chaining, and if you use backward chaining, then the system may not. That's what the guardrail warning also says, right? So it says no, performance is not better in backward chaining. That is a wrong understanding. Performance is almost the same in all of them. Just that if you use this whenever use condition, which is the thing for backward chaining, Pega itself says that performance is going to be bad. Okay, so
the question came because in forward chaining, whenever any of the constituting inputs changes, so if they are changing for 20-25 times, it's going to get calculated. That's why I got this understanding or misunderstanding.
Yeah, that's true. So that's true. Yeah, what you're saying is true. If it changes a number of times, it recalculates. Okay. Now
that's why I had the difficulty in understanding how performance can be better in backward chaining.
Yeah. No. Performance. Okay. So yeah. So now to your question, how it will be better in backward chaining is, so I'm not saying that it is better in backward chaining. It's almost the same, but in backward chaining, it's even worse. That's the concept here. So forward chaining has a better performance than backward chaining here on this condition. So it says whenever used, what this does is, this is a unique feature of backward chaining. What that does is it checks it on all the scenarios. That is, if the property is missing, then it goes and checks the particular logic value, the particular sequence of all the chainings, interdependent chainings, it goes and checks everywhere whenever that particular property is used. So consider this scenario. Now I think we should talk in a more real-time scenarios. So what happens is, suppose you have a shopping cart application, like e-commerce application. Okay, so consider the scenario. So we have e-commerce website. Okay, and assuming you have written Pega. Now what happens here is, the first step here is to collect the goods, select the items. Okay, second option we have is, when we select the items, then you click submit, and what does it do? It calculates it. Then after that you say you review the items. Okay, third option is you say go for proceed to checkout, or say enter address. Next option is proceed to checkout. Now I want all of you to really carefully observe this scenario, because this is pretty crucial for you to understand the performance impact of forward chaining and backward chaining. So say here, now what happens is, now we have hold on. Okay, so yeah, this is all this will be there in the document as well. So right now, if you see here, what's really important for you to understand is, assuming that we have a declare expression which is to calculate the sum. Okay, sum of calculate the total cost, okay, of all items. Simple, right? So you have item 1 plus item 2 is equal to total. Right? Now, assuming that we have a forward chaining declare expression for this item 1 and item 2, then it calculates a total. Now, as and when you select items, it calculates a total for you. So we used forward chaining to get the result here. Now, what's important for you to understand here is, this item 1 and item 2 are going to be changed only on this screen. Okay, it's not going to be modified at all in any of the next screens. So if you apply forward chaining here, it works really well, because only in that particular screen you can change the property values and it recalculates by itself. Now, assuming you go for a backward chaining concept here, then what happens is, see here, so if you go for a backward chaining here, what happens is that this total, okay, that's here, total is going to be referenced, so which means it will always calculate this. We're talking about this whenever use condition. Okay, so what happens is, you select total here. Okay, or the system is going to look for total, and which is internally going to go and look for item 1 count value and item 2 value, and it's going to calculate this total value here. Now, which is all right. Okay, now then the system goes to this review item screen. There as well, if this particular property total obviously will be referenced, then again system is going to go and find item 1 and item 2, and it's going to sum it up again. Okay, then it goes to the next step. Again here also, because whenever the property is used, it's again going to go and calculate the backward chaining for T is I1 plus I2. Now the same concept comes for proceed to checkout also. So the concept here is, whenever that particular property value is used, the backward chaining is going to be triggered, the whenever use condition on the backward chaining is going to be triggered, and it's going to keep on recalculating every time the property is used. That is the reason why generally it's said that backward chaining is worse than forward chaining. But it has actually it has it's that's why it's generally said so. But you should not say that backward chaining is better than forward chaining, but it depends purely on the use case. So if you are going to have this particular property value used in multiple screens, then it does not make sense to go for a backward chaining. You should go only for a forward chaining here. Right? Is this clear? This is very important for you to understand that the backward chaining has so the backward chaining has been it's considered to be this. It has multiple options here. So not all these options are bad. So backward chaining means you can say that if the property value does not exist, then recalculate for the first time. Okay, which is not a bad backward chaining approach. This approach is fine. The other option is when used if property is missing. So again, if the property is missing and we are referencing the property, then we just go and calculate it again. But this whenever used, if you use this option in the backward chaining, that is when you get a guardrail warning as well. It says that it will be referenced in all the screens and it will keep on recalculating all the time, which is not needed for you. Right? Which is not needed based on the business use case actually. So for this business use case, you don't need it for an e-commerce website. But there may be use cases where you want the system to always recalculate that particular property value, then you should go for whenever use condition. Okay, so in that scenario, you have a proper business justification that says that okay, I'm going to go and recalculate this property value all the time, and which is always fine for you. Okay, so the system just gives you a warning that it's obviously performance impact, so you can decide when to use or where to use that. Right, I hope this is clear for you. So yeah, keep in mind that even in interviews, you should be able to explain it like this way, not just simply say that forward chaining is better, backward chaining is, because people mug it up like by heart at saying that backward chaining is bad and forward chaining is good. But yeah, it's not right to say that one is better than the other. Only in this whenever use condition, it's more resource intensive for backward chaining. That's it. Okay, I hope that question was clear, right? That answer is clear. So yeah, I think you can see that in the chat. Okay. All right. Now, I think this is declare expression. Yeah. So we have the exercises. Yeah. For email, I'm not going to do an exercise. Its correspondence is pretty straightforward. Just try it on your machines. For send email, it's there on the support app application that we have done. So there is a send email and correspondence is already there. But just take a look at the email account. But that's all there. But this is important for this tickets. Okay. So we will quickly do the exercises on tickets and the declarative expressions, right? So give me a second. I'm just going to log out and log in into the system to enable the recording for the exercise. Give me just about a minute. Alright, now I'll share my screen and Alright, so we're going to start the exercise now on tickets, and then we will do the exercise on declare expression. Right, so let's get started with the exercise on tickets. So if you would open the ticket here, let's let's close all these. So here, what I can think of an easy use case here. So on the review information, you can have a business exception that we can probably think of putting here on the review information screen, and the 𝐬𝐶 is say, for example, the flow wants it should go to a manager for approval only in some certain scenarios, as in you can give a button, or you can ensure that a checkbox is there which goes to manager for approval and manager for review before even sending it for investigation. Okay, so the business use case here is you want to send it to a manager for approval before even sending it for investigation of the 𝐶 case. Okay, so key concept for you to understand is this is a business anomaly. You can, if it was not a business exception, you could have just simply used it as decision shape to achieve the same requirement. But it's a very rare scenario that this goes to manager for approval. So you can just select this. Right, say for example, you can, so we will change it from this defer tickets. So from this ticket here, I will remove this one. Okay, now what I will do here is so what I'll do here is from the manager approval, I will say that you know what, when it goes to the manager for approval, I will send it back to the review information saying that can you review it again, because I think there might be a problem or something like that. So I can just here into the, I can select the operator as, I can select custom, and I can select to work list, and I will say to work group manager. So this automatically routes it to the manager. Okay, and remember the key concept here again is I haven't hard-coded the manager name, so instead I've used an activity to get the actual, to send it to someone, right? Now here on this, let's see the flow action. So I will give the flow action, out of the box flow action called as approve. So I'll set approve, and then here I will say that I will create a ticket called as review. Okay, so I will say that, or I'll just put it as a reject here. Okay, which is rejected by the manager, and then it's going to be checked again, right? So I will have this option. So I can probably customize this view here. So I can just say the approve flow action here. Now I can just open the section approve. I can save as this into my rule set. So I will say let's put for C time. I will just say work. Right. So in my work pool, I will modify this a bit further. I will give the option to reject. So let's say I will create a property called as review again. So all I can do here is I can just put a dynamic layout because this is from older versions of Pega. So I can give this PY note as a text area. Say, come here. Right, so and just beneath this I will say, for example, I can give a checkbox, something like this, says that reject. Okay, so I will just put a property here. I think we should already have a property like that. Right. So I will create a property just for holding the rejection option. Okay, I can put it as a boolean like true false. Create and close, and I will say checkbox caption send for review again. But I will just say that caption should be on the left, and I will show it here. Now here we can complete this. Alright. Okay, so let's run the flow here. Okay, yeah, even before that, now let's save as a flow action as well, and we will invoke the ticket based on a condition. So it says work. I'll put it as a work pool level. Now here, generally under the action tab, here what we will do as a post processing here, we will run an activity, which is again you have to create an activity for or use an existing activity called a set ticket. Okay, so what this does is this sets the ticket reject. This would automatically do the processing for us, same as setting the ticket. If you open this set ticket property here, this class here, it uses a method called as obj set tickets. If you can create your own activity as well. So I think we'll go ahead and create our own, but know that this is a method that we have to use. So the way to do that is you can either use out of the box activity, but the reason why we can't use it in our case is we want it to check the property value called as dot reject. If it is dot reject is equal to true, then we want to call this set ticket. Okay, so what we will do, we will say that check for rejection, right? And here I will, so generally another good naming practice to give for activities that are given as a post processing of flow action is to prepend to prefix it with the word post. Okay, it says that post check for or you can see that post manager review. Right, this is also a good name convention. Right, or I can just say post review or something like that. Just say post review. Right. So you should always name your activities in such a way that which are used in a flow action, so that it's a lot more easier for people to understand what that particular property is, what that flow action, that activity, or where it's used. So I will say dot. So I will just build the expression here. Say that dot reject equal to true, date, and then I will say that submit what happened here. Say post review. Let me open this again. So I will skip the condition here. We'll say dot reject equal to true. Then if true, continue. Otherwise, I will say that exit activity. Okay. And then here I will say that obj set ticket where is that option, where did it go? I'm not sure why is it not coming in the drop down though, but it's weird. Oh, it's not coming up in the drop down anymore. Something's wrong. Right, so we can just give here, set the ticket name as reject, and the other option. So the thing about OBJ set tickets is that once you set the ticket, it automatically shifts, it executes that. Then you have to remove the ticket immediately after that. So what happens is the moment this executes, the system will automatically go and invoke this ticket, and then it will do all the processing between before it moves out of the step 1. So it will do all the number of processing that it needs to do in the backend. Then immediately after that, you need to make sure that the ticket is removed from that particular work object. Okay, so you need to set remove here. So that remove reject. Okay, so I've just used a when condition. It's just going to say reject as a true, or even easier way to do this is just call the activity call set tickets. Okay, so whatever I did now is the same as what just happened, what the set ticket activity also does. The same thing, it says here set, and then it removes it as well. See here. So it doesn't matter either way, both the ways are right actually. So right now, coming to this one here, we save this, and now what we have, let's now run our case. Right. Let's say party. What does it create? And then say, for example, it right. I hope I saved the flow. Looks like I didn't. Right, I'll save here. Now I just open the flow again just to ensure. Yep, so open the flow now. Okay, I think we had ensured that it was a DWA case, so I should make it to current operator just for testing now. and create from the flow again, like if Alright, so I think we don't have a flow action. Oh man, I think we have one more mistake here. We had to give the information as a flow action here, but let's see here. Okay, because this flow action is not, we haven't defined a flow action on this connector, so that's all right. We can do that later, and then I'll say advance the case, right? So you see here now it's at the manager, it's with the manager, and I think, yeah, I don't think you have the access to do this, so you can just open this approve flow action. There is a privilege by default that is associated to that flow action, so you can just remove the privilege for now. Or I think if you log in as a manager, you should have the privilege. Let's log in as a manager. So I would say manager, and the case is C-39. So this is the one. Open it. Okay. This one. Yep, so you see it came up for me here. Now what I will do here is, if you look at this where am I option here, this location icon, you're at this particular assignment now. Now what I can do here is I can click on this, okay, say that can you review again. I click submit, and you see here now the flow would have come back to this one here. See here, it came back to this one now. Right? Now because I do not have a connector here, that is the reason why it doesn't show up very clearly, but what's important is you are able to jump back easily without any troubles. Okay, so you can modify this flow to look like this as well here on this review information here. You can give this, sorry, you can have this to come up here like this, extend this like this. You can have the review information here. Right. And then you get, so you have the review and it comes here, and if you are rejected, it goes back. Okay. So this is also a use case, and so that's it about ticket. So it's as simple as that. You just have to just invoke this obj set ticket and reference a ticket in that particular assignment shape or whatever utility shape that you have. Right. Right. Now the next thing that we have to look at is the life insurance claim. Now if you go to this enter disease info, that's when you have the grid that we had created for checking if the not checking, actually we had created it for entering the details. So what you can do here is, let's take a look at those properties. So the declare expression here is like very easy to create. All that you need to do is just figure out the right property. So I think if I open the data layer as well, now if you see here the disease data layer here, Now I will just say cost. Say cost of treatment. Okay. Now the data type I can give it as, just say for example, okay, I will give it as this text because yeah, I'll give it as text. Or I don't think I should give it as number. Right, I will give it as integer, right? And then what I will do is here is I will just come to this section here. I will add an additional column, and on this one I will give as dot cost of treatment, and then I will select the control as currency, and here on the presentation, as of now, we'll just leave it like that, whatever the default value is. But on top, I'll say cost of treatment. Right now, here at the bottom, we can add another property. Say, for example, a text input. We can add it here, which will show the sum. Right? So here, if you go to the App Explorer here, and if you open the 𝐬𝐸 and the data model, we want to hold the total cost of treatment, right? So I will create the property here under the 𝐬𝐸 level. Okay, look, keep in mind that this is not going to be at the data-disease level, right? This is at the 𝐬𝐸 level. So we'll say total cost of treatment. Right, I will look at the additional configuration options. Then I'll give it here as integer as well. Say create and close. Now after this, just refresh this App Explorer just to see the property here, and you should be able to see that now on the data model and the property. You should be able to see the total cost of treatment. Now all that you need to do here is on this particular section here, on this text input, I will say dot total cost of treatment, and click submit. Right, so now here, in order to make this declarative, you just right click on this property and you say define expression. So this is all there in the supported course application as well. If you remember, there was something like date of birth calculation or something that was there. Okay, so here I'll just say calculates total cost of treatment, right? And then I will say the page context is, sorry, say dot disease list dot, so page context is dot disease list. I'll say create and open. Alright, I think not here, not the page context. The page context should be a work page itself. Okay, I'll show you here. So it says, I will say that you see all the options here. I will say sum of dot disease list dot cost of treatment. Okay, and I can give a when condition as well, and I can give the condition like this: when if. Do I need an if condition for this? Not sure. I don't need that condition here. I don't need to even check now the values. I can just directly create this sum is equal to total cost of treatment here. Okay. Now, what's slightly interesting about declare expression is that you can run and test it here. So okay, if you just click on run, I think this comes up only with the Internet Explorer. So what happens is it will create, if you guys should try it on an Internet Explorer. So what it does is it will give you a UI like this, where you can enter the details and it comes up like this. You can like test it. If here it's pretty straightforward, but in real systems if you have like a lot of independent rules and all that, you can just easily create it without much difficulties. Like you can just check whether it's all right. Alright, now if you go to the change tracking, always it is whenever input changes. This is a forward chaining. Remember, the other three options are backward chaining, and this is the backward. Right? Now, if you go to our UI now, yeah, this is also fine. And now we just need to go to our case and just create an 𝐿 case C39, and I would say it's with the manager. We'll just say that, go to here, I'll say add work, and I say start the 𝐿 case. Okay, I click submit and say here I will give the name here, say A, and then I will say some diagnosis date. Right. I will say A and then the Q 1200. Okay. You see here it automatically calculated from 0 to 1200. Now I just need to do this here. I say B and I say another 1200 here. And you see here it automatically reconfigured it for me. So that's all that we wanted. So we wanted to be able to add these values, and the system should automatically recompute this grid result. So it's pretty simple configuration here. All that you needed to do was just open that property and just check the declare expression here. So now if you go to Zap Explorer, under decision you should be able to see this declare expression here, the total cost of treatment. Alright, so that was the exercise on using the declarative rule. Any further doubts here? It was a long session. Let me know if there are any doubts, but if not, I think we can call it a day. Alright, yep, I think there's a question. Alright, I think all of you can drop off now. Session is over. We will meet up tomorrow at the same time. Alright, good day everyone. Yeah, Sandeep, tell me.
I want to know a few things. Before that, I want to know